previous experience, okay, can help in this regard, okay. One of the things I would like to also mention that analytically you can also calculate it throughout your actually your path, okay, what is required, because there is an analytical solution is there, okay, for ATS. That's why it actually provides the bounded latency. So maybe network calculus.
I have one question. You have shown that the shaper provides you, of course, control over the latency. Did you do any consideration about what you put in specific stream classes? Like the question comes down to when is a stream, or what is a service in comparison to a stream, so a cyclic service. So have you any investigation data on that point? So how do you define the stream classes at the end?
Okay. So if I understand
traffic classes
correctly, that how we define a stream. So a stream can be defined, it is defined like from a talker to how many listeners. So this way the stream can be defined. There are many ways to identify the streams. Some of them is actually in the specification, or in all of the switches, they provide some kind of mechanism to identify the stream, and that stream can be mapped to the filter, okay? Mapped to a filter, okay? And group of stream can be mapped to a single filter, okay? Or stational, which is ATS in the ATS.
Question I have, in your experiment, were your link speeds all consistent throughout the network, or did they vary? Your experiment show, did they change as?
We did not actually change this, but we did different link speed experiment, okay? But for this one, for this simplified one, we use 1 link speed for whole, okay? But the thing is that this characteristic will be more evident if we utilize different link speed, okay? More evident, okay? Why? Because we can change the priority internally to different hops, depends on the link speed, depends on the requirement, okay? How we need it, okay?
Did you also vary your packet sizes? Or were they all consistent?
Yeah, we did packet variation, yeah. Packet variation, like usually we think the best effort traffic is a little bit longer, the critical traffic is shorter, the critical traffic is a little bit in between, okay? And so we do vary.
Thank you.
My name is Haikam from question, you sort of initially showed the architecture as central compute architecture, but you also showed several portions within the architecture. And you talk about latency, so my question is, when you talk about the edge latency, are you talking just primarily about latency from essential to your sensors and actuator? Have you also considered actually putting some level of control within the actual zonal area itself to make sure you can achieve the type of control within the zonal area? So there is intelligence spread about between the central computing and also the zonal part to allow you to cater for the actual latency question.
Central zonal computing had their own means. It is some computing is happening there, but it is also work as like a forwarding mechanism. Okay? So there we configure it. We configure it. Configure the ATS also there. So this is whole path we configure the ATS. Okay? Not only just one place. Okay?
To build on the same, hey, Khaja, so Tiago's question about how you tested this. As you move to faster link speeds, the latency of waiting for another transmit opportunity decreases, and at multi-gig it can be under a microsecond. But in automotive, you only need to achieve latency to a particular level of latency. So have you established through testing any best practices as to when certain time-sensitive network applications for controlling latency are important, and at what point you would shift to other methods or not worry about them at all?
We did not explore the best practices right now. This is, as we said, that this is actually the new technology, and some of we see that still we need to verify the hardware, and verification of the hardware is required. But okay, and this is another topic, that how we can have a standardized verification and validation of the hardware. Okay, can be done for ATS. Okay, so the thing is that as we can move, we can come up with some best practices for not only for actually what scenario you are saying, but actually the best practices for how to come with the right set of configurations.
This is a great future.
Yeah.
Any additional questions? All right, great. Thank you very much, Khaja. Okay, we're a few minutes ahead of schedule, which is going into the break, which is actually good because that will give you more time to visit the exhibitors, both in halls A and C. I can't remember which one's which. So we are going to, there should be coffee, or should be coffee shortly, in those exhibit rooms. And we are going to resume the program at 11 o'clock. And we'll see you at 11.